All right, guys. Okay, let's let him focus. What we're starting today is Chapter 7. Chapter 7. And Chapter 7 is going to focus on rational equations and rational functions. And we say rational, we mean fractional. Now, we dealt with fractions before. We worked with them because, we've had 2/3, x over 4. And now we're going to start looking at when x is in the bottom of the fraction. So x, the variables can be in the numerator and denominator, and a lot of the ones that we'll have will either have them in both or specifically on the bottom of the fraction. But before we get too far into that, we're going to first start talking about direct and inverse variation. So direct variation comes in the form of y equals a times x. Now, a is just a constant term. It's just a number. It can be an integer, 1, 2, 3, 4, negative, 1, 2, 3, 4. We can have a positive, negative. We can have a fraction. We can have a decimal. We can have any number, real number, for our a. And x and y are just variables. Now, we can get the a by itself. And when we do that, we're dividing both sides by x, telling us a is equal to y over x. So really, in either one of these two forms, it's considered to be direct variation. Now, we do technically have a third version of this, bless you. And that's just saying a is equal to x over y. Because x over y, y over x are the same thing, because x and y are just our variables. So if we do see an equation in the form of y equals a times x, a is equal to y over x, or a is equal to x over y, we would consider this a direct variation. Now, direct variation has one specific thing in common, especially when we look at numbers. The two values, our two variables, are going to vary directly. As one increases, the other is going to increase. As one decreases, the other will decrease as well. We consider that a direct variation. Because one of these, a type of direct variation, is cost and demand. As demand goes up, cost goes up. As demand goes down, cost goes down. They vary directly. The other type that we can have is inverse variation. Two variables, x and y, show inverse variation when they relate as following. Y is equal to a divided by x. Or we can solve this for a by multiplying both sides by x, which tells us that y times x is equal to a. These are kind of the two main ways we can have inverse variation. Now with inverse, we really only have two ways to write it. We have y is equal to a over x, or x times y is equal to a, because x times y, y times x are the exact same thing. Now technically we could have it as, and I'll write this in, x is equal to a over y. We don't normally write it this way because for the most part we consider x to be our input, y to be our output. So if we get them on either side, we normally try to keep the y variable out of the denominator, but it is possible to have it in this setup. Now I did give an example of direct variation. Inverse variation, when we talk about inverse, they're going in opposite directions. As one goes up, the other's going to go down. Or as one goes down, the other's going up. Because we could do that for class numbers. Because the number of students that enroll goes up, the number of empty spots goes down. As the enrollment goes down, the number of empty spots goes up. We could say it was filling a car with gas because the more gas you put in the car, the less emptiness the tank has, or how much we have left. Or as you drive, because as you use gas, the amount of gas goes down, the number of miles driven goes up. There's different versions of inverse variation where we're going in opposite directions. But in any case, there is still a constant A that defines this variation, this constant amount for any of these here. Because direct variations are going to go up in a constant amount, or inverse, there's going to be this opposite movement in a constant amount. In either case, there's going to be a constant amount of change, either in the same direction or in opposite. Now, if we look at these three, well, 9 here, the first thing we're going to do is define them as direct, inverse, or neither.
Bass and music, please come to the office. Bass and music, please come to the office.
Now, in years past, these were on different slides, but this year I decided to put them all together because there's not a lot to it. Because if we look at the first one, A, x times y equals 5. We want to determine if it's direct, inverse, or neither. And all we have to do is look at our different versions because we have x and y together. If we have them together and they equal a number and amount, it is indeed inverse. It's an inverse variation. We're going to skip B for now, but I'm going to look at C. Y over 2 is equal to x. Now this one out of the 3 is a little harder to see because we have y over 2 equals x, yes? Now looking at all of them, when x and y are on opposite sides, for inverse, one of the variables in the numerator, the other's in the denominator for inverse, yes? For the one we're looking at, C, x and y are either one of them in the bottom of the fraction. No, they're both in the numerator, yes? If they're both in the numerator on opposite sides, it can't be inverse. We're actually looking at direct. Y is equal to 8 times x, or we could actually say x is equal to a times y, yes? So this is direct. A different color. Because we do have, and I can rewrite this and have x on one side. And we can have y. But the way that we get y over 2 is that we're really multiplying y by 1/2. So for C, the actual value of A is 1/2, not just division of 2. It's 1/2 y, or y over 2. Questions on A or C so far? Now looking at direct and inverse, and we'll go back, and this leads us to B. There's only really 2 operations we're using for any of these here. It's either what? Multiplication or division, yes? In any of these here, do we have addition or subtraction? So what do we think about B? It is neither. Because that's going to be the big giveaway for neither. So let's look at the next 3. 1, 2, 3. 6x equals y. Direct, inverse, or neither? Direct. Because if we look back at our main types, because we have 6x times y is equal to a times x. Our a value is 6. So this is direct. We're just trying to match it up with one of our types. Number 2, x times y is equal to negative 0.25. Inverse, our x times y equals a. A in our case is negative 0.25. Addition tells us it is neither. Questions on these here? We good with the first 6? Your focus on that. Now y'all have a little more space to the right for the last set of 3. I'm gonna write over the top of them because as y'all can see, I've run completely out of room for those 3. But we can still do these here. Because if we look at A, x times y equals 17 would be inverse. Y equals 17, x times y equals A. Our A value is 17. If we wanted to get it in the actual version for inverse, we could divide both sides by x, telling us y is equal to 17 over x. We just divide both sides by x. Xy becomes y. The other side is 17 over x. B, y equals x plus 29. Neither. Our addition gives it away. C, y over 10 equals x. Direct. Because we can multiply both sides by 10, and it's telling us y is equal to 10x. How do we feel about this so far? We ready for what's next? Tell whether x and y show direct, inverse variation, or neither. Now, when I talked about direct and inverse variation, we said the amount that they vary is always constant. There's always a constant value of A. So the amount of change from one number to the next should always be the same. So we can go back over here. I don't like the 1/2. I'm going to use this one over here. And it's not that it's so bad we get some weird numbers, but y equals 10x we said was direct variation, yes? So, x. Well, when x is 1, y is equal to 10 times 1, so y is 10, yes? When x is 2, so we can say y is equal to 10 times 2, 20. And we see here, as x increases by 1, the y values increase by 10. There's a constant amount, a constant change from one term to the next. And we could keep doing this. For 3, it would be 30. 4, it would be 40. And we can keep going on, yes? So if I divided, or I multiplied, or sorry, so here, we get the same amount. Now, we also said direct was y over x is equal to A, yes? And it gives us that constant amount. The constant amount's by itself. So here, if I said 10 divided by 1, we would get, obviously, 10, yes? What's 20 divided by 2? 10. 30 divided by 3? 10. And 40 divided by 4 is 10. Because what did we say the constant amount for this one here was? 10, yes? And because it is direct, our y over x gives us this here. We could have done x over y. But if we did x over y, we would have had 1 over 10, which is 1/10. 2 over 20, which is still 1/10. 3 over 30 is 1/10. 4 over 40 is 1/10. We do to get that constant amount. So, when we're looking at this here, we're going to be using the same types deal, because our direct, our y over x was equal to A. Inverse, x times y is equal to A. Because if we take y and divide it by x and get a constant term, the same amount each time, we know it's direct. If we multiply the two together and get a constant term, the same amount each time, it's inverse. But if neither one give us it, then it is neither. So for A, first thing we need to do is determine, do we want to check to see if it's direct or inverse? We can do direct first. So our direct is y over x is equal to A. So we can pick the first one. Negative 12 over 2 is negative 6. And we can plug that in the calculator. Negative 12 divided by 2. We get negative 6. Then we'll move to the next one. Negative 6 divided by 4 is negative 1 point. Negative 12 over 2, negative 6. Negative 4 over negative 6 over 4. Yes, I knew that. Seemed a little weird. 3/2, negative 1.5. Are those the same? Is negative 6 the same as negative 1.5? No. So what we can say is that this here for A is not direct. Now the next one we can check is inverse. And inversely, if we multiply the x and y values together, we should get a constant amount. So the first one we can do is negative 12 times 2. Negative 24. Then we do negative 6 times 4, which is negative 24. Then we can do negative 4 times 6, which is negative 24. And lastly, negative 3 times 8 is, so this here is inverse. And that's it. The nice thing is if, just like with direct, as soon as one of those numbers doesn't match, we're done. We don't have to check them all. Because the other two could have worked fine with direct, but since one of them doesn't, not direct. But we do need to make sure to check all of them if it is working. We ready for letter B? Do we want to check direct or inverse first? Direct. So our direct is y over x is equal to A. And our first one we can do is 2 over 1, which is 2. From there we can move on to the next set of numbers, 4 and 2. So 4 over 2 is 2. So this is looking promising, yes? So we can say that this is direct variation, yes? No. Because what's our next one? So this looks like it did, especially it started out looking like this was direct variation. But once we went out 3 spots, it went away from that. And especially if we continued on, 16 over 4 is 4. It is not direct. So we can move on to inverse. Well, our first one's nice. 1 times 2 is 2. Our next one, 2 times 4 is, okay, we don't even have to go any further because that's not the same. This is neither. More specifically, this is actually an exponential function, giving us to us by the equation y is equal to 2 to the x. Because when x is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and 2 to the fourth is 16. So it's neither. We don't have to put the equation. I was just giving that to you so that we can see. We're ready for number 1, I believe. Number 4. There we go. I didn't know if it was going to switch over or we going to. Yes. Now, one thing I will bring up over here, because whichever one we check first really doesn't matter, but we said direct. If it's direct, they're going in the same direction, yes? Opposite, inverse is opposite. So if we look at A, we said A was inverse, yes? Because here, well, we said A was, yeah, inverse. Because one is going up and the other is going down. One's going away from 0, one's going towards 0. If we look at number 4, the x is going towards 0, the y is going towards 0. So they're going in the same direction. And we can check direct first. Y over x is equal to A. So the first one we'll have is 20 over negative 4, which is negative 5. Our next one's 15 over negative 3, which is negative 5. 10 over negative 2 is, and lastly 5 over negative 1 is negative 5. We didn't have to do this, so this is direct. I was getting ahead of myself. Because y over x gives us a constant term of negative 5 for each and every single one, so it is direct. Now the formula for direct is y is equal to a times x, yes? So here, if we filled that value in, the equation would look like y equals negative 5x. And for the most part, especially for these here, it's not asking for that. It's just asking us, is it direct, is it inverse? Questions on number 4. We go with number 4. Let's look at number 5. Do we want to do inverse or direct first? Inverse. Yes, because our x's are going away from 0, 1, 2, 3, 4, they're getting bigger. The y's are going 60, 30, 20, 15, they're getting smaller. They're going towards 0. So the first thing we can do is 1 times 60, which is, our next one's 2 times 30, which is, 3 times 20 is, and lastly 4 times 15 is. So does that give us the same amount each time? So we can say that this is inverse. And if we wanted the equation y is equal to a over x, well, this one here would be y is equal to 60 over x, because that's our value of a. A was 60, that's our constant amount we get each time. And the equation would be y equals 60 over x. Here, it's not asking for it. There will be ones towards the end that will ask for us to find the equation given x and y, and then solve for a specific amount. But questions on 4 and 5? We like these so far? Do we need to see another example of one of these two? Okay. So if we look at this here, tell whether x and y show direct variation, inverse, or neither. Now again, so here x is increasing, y is decreasing. Even if we don't see that, we just need to pick one to try. So we can try inverse first. Inverse variation, and the one we're going to use is either x times y equals a for inverse, or y over x equals a for direct. We want that form where the constant amount is by itself, whatever that a is. So here, x times y equals a. So the first thing we're going to do is 2 times negative 6. Then we'll do 3 times negative 4. 4 times negative 3. And lastly, 6 times negative 2. Since we have the same amount each time, this is inverse variation. Let's get this light green. Now, we did inverse. Our x times y equals a is the inverse. Now, we don't even have to do direct, because if it's 1, it can't be the other. Because our direct y over x is equal to a. So for the first one, it'd be negative 6 over 2. Well, negative 6 divided by 2 is negative 3. Well, it's not that. I'm thinking of fourths. Because this here, negative 4/3 would be negative 1.3 repeating. And again, for direct and inverse variation, we need this constant change from one term to the next. It should be constant. Amount in negative 3 and negative 1.3 are not the same. That's not the same amount of change. So it is not direct. So if one of them works, the other one won't automatically. And as soon as we come across one that does not match the same pattern, we throw it out. It's not going to work. So B. Colby, looking at this one here, do we want to try direct or inverse first?
Inverse.
Okay. So we'll do x times y equals a. And the first one I have is 2 times 24. 48. Four times 16. They're not the same. Since we have a different amount each time, it's not. It's not inverse. So then we can look at direct. Y over x is equal to a. So we have 24 over 2 is
Wait a minute, what? Oh, divide.
divide. 12. 6 over 4 is
So the numbers have to match up.
because the amount of change has to be the same for any spot along that line. It has to be increasing or decreasing by that amount. Bless you. Questions on this here?
Inverse is times and direct is divide.
And the reason that is because direct variation comes in the form of y is equal to a times x. Well, if I want to get this a by itself, I need to divide both sides by x, because this here, the x and x would simplify, giving us a by itself. But on the other side, we have y over x. So a is equal to y over x. That constant amount is equal to the y value over the x. Inverse. Y is equal to a over x. Here, if I multiply by x on both sides, left side we get xy. On the right side, we have a times x over x, yes? Anything divided by itself is 1, yes? So the x over x would simplify, telling us a is equal to x times y. So we have a by itself. We have that constant amount by itself. So we can determine if it is direct or inverse. Does that make sense? This is the last part of the lesson. The variables x and y vary inversely. And when y is 4, x is 3. Write an equation that relates x and y. Then find y when x is negative 2. So one of the first things we're asked, because this is asking for 2 things, is to find the equation, y equals a over x. We want to find that equation. We want to find the value of a that makes this true. Then we want to find the y value when x is negative 2. Yeah, x and y vary inversely. So y is equal to a over x. Now they do tell us something important right here. And y is equal to 4 when x is 3. They don't tell us a, but they tell us it's varying inversely. When y is 4, x is 3, yes? So we know they vary inversely. Y equals a over x, yes? So for us here, they're telling us the y value is 4 when the value of x is 3. Whatever the value of a is, when I plug 3 in for x and simplify, it comes out to be 4 for whatever value of a we have. Yeah. But to get a by itself, we're going to multiply both sides by 3. Because here the 3 over 3 will cancel, giving us a by itself. 4 times 3 is 12, so the value of a is 12. So our equation, y is equal to 12 over x. That's half the answer. We want to write an equation that relates x and y. So this first part here is just telling us it works. And we could, because 12 over 3 is 4. That's just kind of verifying that it is true. But we don't need that part. Because our main first goal is to get the equation, y equals 12 over x. Second part, yes? Then find y when x is. So we're going to do for this part. So 12 over x. Exactly, so y equals 12 over negative 2. We're plugging that value in for x. Negative, or 12 divided by negative 2 is? That's our full answer. So the equation is y equals 12 over x. And the value of y when x is negative 2 is y is equal to negative 6. That's it. We'll do a few more of these, especially on the homework if it doesn't reduce nicely. So the first part, those really, let's see here. So these here that we listed out for direct and inverse, that's all we're looking for. Is it in one of those two forms? And A is just going to be a number. In direct, there's two versions of direct. Either the variables are on the same side or they're on opposite. And when they're on opposite sides, they're both in the numerator. Neither one's in the bottom. Yeah. But when they're on the same side, one is on top of the fraction, one's on bottom for direct. Inverse, when x and y are on opposite sides, one's in the numerator, one's in the denominator, or vice versa. For inverse, yes. And if you're having a hard time seeing it, try to get one of the variables on either side. Because really we're seeing if it's in one of these two forms. Now, if there is addition or subtraction, it's neither. Because addition and subtraction immediately tells us it's neither. Yep, try to match it up to one of our forms. And A is just going to be a number. It can be a whole number, 1, 2, 3, 4, negative 7, negative 14. It could be fractional, 1/2, 1/4, 1/5. Because x over 2 is just 1/2 times x. You're welcome. Variables x and y, or the variables x and y, vary inversely. When y is 8, x is 4. Write an equation that relates x and y, then find y when x is negative 16. So y is equal to a over x is our general form. And y is 8 when x is 4. So to get a by itself, we're going to multiply both sides by. Here, the 4 and 4 cancel. And 4 times 8 is 32. Now our equation is y is equal to 32 over x. Questions on how we found the equation? Now, good question would be, is there any time we're going to have to do anything to the equation besides just plugging it in? And the answer is yes. And that comes into play if a is fractional or a decimal. Because we cannot have a fraction in a fraction. So this here would be an example of it. But what we're saying here for the left-hand side is that we have 1/2 divided by x, yes? Numerator divided by denominator, that's all a fraction is. To divide fractions, we keep, change, flip. Multiply them together. So here y is equal to 1/2x. That's all we have to do to simplify it if there is a fraction. In that case, I know the print on your note sheets is a little small. Let's look at it first. Right. Did not mean to do that. I have to fix that. I realized I was so quick to jump to it. We never finished this one. Because we got the equation, we just didn't find y when x is 32 over next 16. So y is indeed -2. So it's just plugging it in and solving. Now again, with these here, when you solve for y, and especially on the homework, if it does not reduce nicely, and when I say nicely, it's a repeated decimal. So if this had been 31 over, or 32 over 31, that's not a nice decimal, it doesn't reduce nicely. You can leave it as that. Even if it does, if it's 7/3, well, 7/3 doesn't reduce nicely because that'd be 2 1/3. Leave it as 7/3. If it reduces to an integer or without a decimal, reduce it. If it doesn't, you can leave it in fractional form. Yeah, you can leave it as an improper fraction. Now, let's look at 8. And funny enough, even though 8x is 1/2, it's actually going to work out nicely. Because they told us here, y is 16 when x is 1/2, yes? What can we do to get a by itself? We can multiply both sides by 1/2. Because here the 1/2 and 1/2 will cancel. Now we want to find the value of y when x is -2. Now, yes, it doesn't say it right next to the x and y. But the instructions for this here, is it just 2?
Yeah, it's just 2.
Thank you. There's just 2. And I believe it's going to do the same thing on the homework. It's going to give you a set value for each and every single one in the instructions. And that's it. Questions on this here?
No.
Do we need to see another example of one of these here? Yep. Apparently not. But that is it. 368, 3 through 8 is determined direct inverse or neither. 11 through 14 is the same thing with the table. And 15 through 18 is what we finished up with.
All of them but 2.
Yep. Here you go.